In two previous videos, I discussed the utility and risk preferences for investors. And I wanted to continue that discussion by discussing how we measure risk aversion. Now, we generally assume that investors are risk averse. But how risk averse are they? And risk aversion essentially means that an investor gets greater utility from certainty than from a gamble that has the same expected value. So the question is, how can we measure risk aversion? And risk aversion is essentially measured by the curvature of the utility function. So let's take a quick recap here. And we had this graph before in the previous videos where we talked about if it curves downward this way, then this is the case where you are risk averse. A risk neutral investor will have this utility function between utility and wealth that's a straight line, and a risk lover, it will curve upward. Now, I've drawn a picture here of two different utility functions. The black utility function is a little bit less curved, and the red one is a little bit more curved. And what we have here is, if you recall from the previous video, this line here. So we have three different levels of wealth. And here we have the expected value, the average of the two. Now, the fact that this is curved this way means that as you draw from, let's say, wealth 2 up to, let's go up to the red utility function, you get this level of utility. And you only get this level, the average between the two. That's this dashed line that goes between W1 and W3, but has the same expected value, is lower. And likewise with the black one. Okay, here's what the expected utility would be from the gamble. Here's what the utility would be from the certain thing. So you'll notice that the difference between these two is greater up here, greater for the red utility function because it's curved more. That means that this person who has this utility function has greater risk aversion. You see there's a greater difference between the expected value of the gamble and the utility of the expected value of the gamble and the utility from the certain receiving the money with certainty. It's greater than this one. So that's greater risk aversion. All right, how do we measure that? Well, we can measure that by creating a couple of measures. The first is called absolute risk aversion. Absolute risk aversion is a measure of investor reaction to uncertainty relating to dollar changes in their wealth. And because the second derivative is negative, the second derivative of the utility function, because it curves this way, it's concave, we're going to take the negative of this so we get a positive number here. All right, what we can do now is we can take the first derivative of this absolute risk aversion function, and it tells us how investor behavior changes with respect to wealth. And I've got a little table here. If it's positive, we call that increasing absolute risk aversion. And that means that as wealth increases, that investor is going to hold fewer dollars in risky assets. If it's equal to 0, that's what we call constant absolute risk aversion. This is the case where as wealth increases, you hold the same dollar amount of risky assets. And then if it's less than 0, we call that decreasing absolute risk aversion. As wealth increases, you hold more dollars in risky assets. So if you sort of think about it from a common sense perspective, it doesn't really make sense for someone to exhibit increasing absolute risk aversion. Okay, as you get wealthier, it doesn't make sense that you'd actually hold fewer dollars in risky assets. I mean, I suppose it's possible, but it doesn't seem likely that if you went from having $10,000 in wealth to $20,000 in wealth, that you would actually have less money in risky assets. I suppose if you're extremely wealthy, you might not need to hold any risky assets because there's no reason to. You could have it all in treasury securities, and that would be just fine to finance your expenses. So actually, the one that makes the most sense is decreasing absolute risk aversion. As you get wealthier, you're probably going to have more dollars in risky assets. You'll also have more dollars in safe assets as well. Okay. The second concept we'll look at is something referred to as relative risk aversion. And this is a measure of investor reaction to uncertainty relating to percentage changes in their wealth. And it looks basically the same as absolute risk aversion, except you multiply by W here up in the numerator. So it's really W times absolute risk aversion. And I've got a table here. We'll go and we'll, again, take the derivative, the first derivative, to see how relative risk aversion behaves with respect to changes in wealth. And if we look at this table, if it's greater than 0, if the first derivative is greater than 0, you have increasing relative risk aversion. This is the case where the percentage invested in risky assets declines as wealth increases. If it's equal to 0, we call that constant relative risk aversion, and that's the case where the percentage invested in risky assets is unchanged as wealth increases. And if it's less than 0, we call that decreasing relative risk aversion. And this is the case where the percentage invested in risky assets increases as wealth increases. This is not quite so clear which one would be obvious. In the case of absolute risk aversion, it seems that decreasing absolute risk aversion makes sense. Here it's not really so obvious. In many cases, we assume constant relative risk aversion, not because we have empirical evidence or that it makes common sense, but just for simplicity purposes. So let's take a look at a couple of examples here. A common utility function is the quadratic utility function, and we can write that as W minus B times W squared. And if we take the first derivative, we get 1 minus 2BW. If we take the second derivative, we get minus 2B. So the absolute risk aversion is going to be minus the second derivative of the utility function divided by the derivative of the first derivative of the utility function. And we get 2b over 1 minus 2bw. If we take this derivative, we get 4b squared over 1 minus 2bw quantity squared, and that's positive. So this is going to exhibit increasing absolute risk aversion. Likewise, we can come up with the relative risk aversion, W times the second derivative divided by the first derivative. And if we work through that, we get that this is positive. So this person exhibits increasing relative risk aversion. So this does not seem very realistic of how people would behave. Okay? It doesn't seem likely that people would hold less dollars in risky assets as wealth increases, and that they would also hold a lower percentage of risky assets as wealth increases. Possibly increasing relative risk aversion may work. Okay, again, as you get wealthier, you don't have to take as much risk, because if you're very, very wealthy, you can hold your money in very safe assets. But the first one doesn't really make much sense. Let's take a look at a second utility function, the log utility function. And we're going to define the utility of wealth as a natural log of wealth. First derivative is W to the minus 1 power, and the second derivative is minus W to the minus 2 power. And again, if we work through the absolute risk aversion measure and then take that first derivative, we find that this person exhibits decreasing absolute risk aversion, which seems to make sense, and constant relative risk aversion. So this is the case where As this person becomes wealthier, they hold more dollars in risky assets, and as they become wealthier, they choose to hold a constant percentage in risky assets. So this seems more realistic in terms of how people are likely to behave. But again, these two measures are a way to quantify the level of risk aversion of an investor.